Our next story begins in London, where of all the brains in the world, few have been changed more than the one behind the wheel of a London taxi cab. No one can drive a traditional black cab in central London without first demonstrating the knowledge, a mental map of London's maze-like streets.
Can you take me from Winfield House, the American ambassador's residence, to Old Bond Street?
Leave right over gate, left Park Road, bear right Baker Street, full Portman Square, left into Wigmore Street, right Welbeck Street, left Henrietta.
Scientists recently scanned the brains of 16 volunteer London cabbies and discovered that they all possessed a larger than normal hippocampus, the area of the brain used for packaging memories before they're stored. Only months before, an even more astonishing discovery had been made about this same region of the brain.
So this is the imaging room where we...
Fred Gage, here at the Salk Institute in California, led a team that found brand new neurons in the hippocampus of Swedish cancer patients. Before they died of their disease, these patients had volunteered for a study that labeled any newborn cells in their bodies with a bright green dye. This is a slice of brain tissue from the hippocampus.
The green corresponds to the molecule that was injected into the blood of this patient 2 years before they died, which means that that neuron was born when the patient, in this case, was 62 years old. And at some later time point, it became a mature neuron in their brain.
So that was a clear indication that there were cells dividing in this mature person.
Yes, yes. So from these
this discovery has set the field of brain science on its head, overturning the long-established dogma that once we're adults, we only lose brain cells, never gain them.
There were not only cells dividing, but cells that were becoming neurons in the adult brain.
Today, research labs all over the world are scrambling to understand the implications of this discovery. The starting point for much of this work was a study of rats done at the University of Illinois. When rats were raised in an environment that's more interesting and challenging than the usual lab cage, their brain cells made many more connections. But there had never been any hint that they also made new neurons until Fred Gage and his colleagues set up a similar study with mice. Not only did they find new neurons, once again within the hippocampus, but mice living a more interesting and active life had more new neurons than did mice sitting around being bored. The mice had running wheels as well as toys in the cage. To find out if simple exercise had anything to do with growing new brain cells, the Salk team gave some mice just a running wheel.
To our surprise, we found that the mice that were housed just with the running wheel had the same number of newborn brain cells as the enriched environment, suggesting that just physical activity or exercise alone can generate new brain cells.
Having new neurons sounds good, but do they do any good?
This is his very first time in the pool. He's never been in the pool ever before in his life.
Henriette tested her mice for their ability to find a platform hidden just beneath the surface of the milky water. He doesn't even know there's a platform, huh?
He doesn't even know this. He knows nothing.
Has he found it?
He's found it, but basically he's being lucky. Usually it takes about 2 or 3 days for the mouse to learn this task. And 7 days of training for him to learn it really well, to reach this, for me to put him in the pool and he'll swim to it in one straight line in 2 or 3 seconds.
Henriette compared the time it took for both the exercised mice and mice housed in standard cages to find the platform.
Place it in the water.
Do they tend to go around the outside and then start to look in other pads?
Yeah.
Whoa, they found it.
It actually turned out very well for the mice on the running wheel because they managed to escape from the water faster in a shorter amount of time than the mice housed under the standard conditions. So this suggests that these mice have learned better and that they're smarter.
So running mice not only grow more new neurons, they also seem to be benefiting from all that extra brain. Have you started running?
I've started and stopped running.
But that's, we all do that. Like I said, did you start because of this? And why did you stop?
I started because of my experimental results and because of looking at my slides with this dramatic increase in new brain cells. But it's you have to be pretty disciplined to keep it up and keep running every day.
So are you maybe hoping that further experiments will show that you don't actually have to run, that maybe just rocking in the chair is enough to do it?
What worried me is that these mice were running like 12 hours every night, and I wondered, how could we run enough to even compare to that? So we did one experiment where we brought down the time of running to 4 hours every night for 5 days, and we already found a 30% increase in cell division just after that short period of time. So I'm hoping that we can bring it down to
it's something that we can handle.
Right.
Yeah. Good. Call me when you find out.
Okay.
The task now is to find out just how running or an enriched environment creates new neurons. Growing cells in a dish outside the brain is one way the Salk researchers are exploring this question. These are brain cells actually dividing under the microscope. The hope is to discover the chemical signals involved and then find ways to use these chemicals directly to grow new neurons, perhaps even in the brains of people such as Parkinson's or Alzheimer's patients who have lost their neurons to their disease. In the meantime, I'll never think of my own brain in quite the same way again.